Good morning. So in last class we have completed the theoretical aspect of complete electrochemistry chapter. Okay. And in last before class, we have done some numericals. So based upon conductivity, conductance, molar conductance, equivalent conductance, etc. Okay. So now let us discuss some more examples. Okay. Take down the question. The conductivity of 0.1 molar 0.1 molar KCl solution is 0.1 molar KCl solution is 1.29 Siemens per meter 1.29 Siemens per meter if the resistance of the cell filled with full stop if the resistance of the cell filled with 0.1 molar KCl is 0.1 molar KCl is 100 ohms. The cell constant is directly you can do. How? So here we have one expression. Okay. K is equal to G into L by A. So where K is conductivity, G is conductance, L by A is cell constant. Directly you do. What will you get? So resistance is given now here. So K is equal to, instead of G, that is conductance, you can take it as reciprocal of resistance. That is 1 by R into L by A. Here you want L by A. L by A is nothing but your cell constant. Okay. So what will be the answer? So just it is cross multiplication. Okay. So what will be the answer? Tell me. Tell me the answer. So yeah, 1 by R is given as 1 by 100 ohms. Okay, K is given as, it is 1.29 Siemens per meter. What will be L by A? So L by A, that is cell constant. Actually L by A means. So cell constant is equal to K into R. That is 1.29 Siemens per meter into resistance. That is 100 ohms. That means it is 129. What are the units for cell constant? Length by area. So length means centimeters. Area means centimeter square. So that's why what are the units? 129 centimeter inverse. That is very important units. Okay. So likewise, simple questions will be asked in your exams. BITSAT and MSAT. Okay. Actually, these are the previous questions. Next, you take them. Now we will move to Kohlrausch law. Okay, because that is the next aspect. Next, take down. Calculate molar conductance at infinite dilution of calcium chloride and magnesium sulfate using the following data. So lambda 0 of Ca2 plus ions is lambda 0 of small letter lambda, that is ionic conductance. Ionic conductance of calcium ion is 119 Siemens 119 Siemens centimeter square per mole. 119 Siemens centimeter square per mole. And lambda 0, that is ionic conductance of chloride ion is, ionic conductance of chloride ion is, ionic conductance of chloride ion is 76.3 Siemens, 76.3 Siemens centimeter square per mole, per mole. Then ionic conductance of Mg2 plus ion is, ionic conductance of Mg2 plus ion is 106, 106 Siemens centimeter square per mole, Siemens centimeter square per mole. And lambda 0 of sulfate ion SO4 2 minus is 160 Siemens centimeter square per mole. So ionic mobilities are given. So you have to find the molar conductance at infinite dilution of these two electrolytes, the mixture of these two electrolytes. Okay. So already I gave. So here this is molar conductance at infinite dilution of calcium chloride is equal to what? It is equal to half into lambda 0 of Ca2 plus ion plus lambda 0 of Cl minus ion. Okay. Or if you want this as one more, then it is also equal to lambda 0 of Ca2 plus ion plus lambda 0 molar conductance of 2Cl minus ion. So this is at infinite dilution. Okay. So similarly, for magnesium sulfate at infinite dilution, molar conductance of magnesium sulfate is equal to lambda 0 of Mg2 plus ions plus lambda 0 m of SO4 2 minus ion. So already these are given. Directly add, and by adding these two, you will get the final answer. Okay. So for calcium chloride, so what is calcium ion mobility? So calcium ion mobility is given as what? 119 Siemens. 119. Sorry. 119 Siemens. Okay. Plus chloride ion mobility is given as 2 into how much? It is 76.3. Okay. What is this? Just you find this. Okay. Then directly magnesium and sulfate ions you add. So when you add all these, what will be the mobility here? What will be the molar conductance at infinite dilution? So it is equal to 119 plus 2 into 76.3 means it is equal to how much? 119 plus 2, 3 the 6, 2, 6 the 12, 2, 7 the 14, 15. 152.6. So if you add these two, you will get how much? You write 271.6. Okay. Then for magnesium sulfate, magnesium ion and sulfate ion. Magnesium ion mobility is given as 106. Okay. Sulfate ion mobility is given as 160. So that means it is 266. Okay. So ionic infinite dilution magnesium sulfate molar conductance is 266. So what would be the total conductance at infinite dilution? Simply you add 266 plus 271.6. Okay, then you will get total conductance if they are mixed together. Okay. Next, take down. The equivalent conductances of sodium chloride, comma, hydrochloric acid, sodium chloride, hydrochloric acid, and sodium acetate, at infinite dilution are 126.45, 426.16, 126.45, 426.16 and 91 more centimeter square per equivalent respectively at 25 degrees Celsius. Calculate the equivalent conductance of acetic acid at infinite dilution. So actually it is application of Pohl's law of independent migration. Okay. So what is the main application of Pohl's law of independent migration? By using this, you can find the molar conductance at infinite dilution of weak electrolytes. So here acetic acid is a weak electrolyte. So you have to find molar conductance at infinite dilution of acetic acid or equivalent conductance of acetic acid at infinite dilution. This is, we don't know, that you have to find. So what is the data given? So data given is, so infinite dilution of molar, what is called the equivalent conductance. So write EQ because equivalent conductance is given. So the equivalent conductance at infinite dilution of HCl is given. It is a strong electrolyte. What is this value? 426. Tell me. 426.16. Okay, more centimeter square per equivalent. Next, equivalent conductance of another strong electrolyte, that is NaCl is given. Okay, what is that NaCl? It is 126.45 mole per centimeter. Okay, next, equivalent conductance of sodium acetate is given, CH3COO So what is that? It is equal to 91 what is called more centimeter square per mole or Siemens centimeter square per mole. Okay, you write Siemens centimeter square per mole, same units. So you have to find equivalent conductance of acetic acid. So here, what do you mean by equivalent conductance of HCl? So this is ionic conductance of H plus ion plus Cl minus ion is equal to this. Na plus ion plus Cl minus ion is equal to this. CH3COO minus plus Na plus ion is equal to this. But we want only equivalent conductance of CH3COO minus plus H plus. That is nothing but equivalent conductance of acetic acid. Actually, required equation is this. Okay. So now what you have to do? So here in your product, acetate ion is there and H plus ion is there. Okay. So in these three electrolyte, in which electrolyte H plus ion is there? In first electrolyte. In which electrolyte acetate ion is there? In third electrolyte. So that's why first and third you should add. Then you have to subtract the second one. Okay. 1 plus 3 minus 2 will give the equivalent conductance of your acetic acid. Already I explained in last class. I think it is clear now. Okay. Now find what would be the equivalent conductance of acetic acid. 1 plus 3 minus 2. Got it? Because here H plus is there in first equation. Acetate ion is there in third one. So that's why you want this plus this. So that's why 1 plus 3 minus 2. 1 plus 3 minus 2. Do 426.16. Okay, plus 91. So that is 6, 1, 7, 11, 517.16 minus 126.45. So 45 means 4 minus 5 1. 1 400 11 7. Then 660. 11 9. So here 390.71. So 390.71 Siemens centimeter square per mole. So this is the equivalent conductance of acetic acid. Okay, got it? Next, the question. Take down. The conductivity of 0. The conductivity of 0.0010 0.00102 0.00102 molar acetic acid is 4.95 into 10 power minus 5 4.95 into 10 power minus 5 Siemens per centimeter. Siemens per centimeter. Calculate the dissociation constant. Calculate the dissociation constant of acetic acid if molar conductance at infinite dilution. If molar conductance at infinite dilution of acetic acid is 390.5 Siemens centimeter square per mole. I think the question is understood. So here conductivity is given. Okay, conductivity, that is K is given. You should first find molar conductance at the given concentration of the electrolyte. Okay, lambda MC you should find. Okay, how can you find lambda MC? Already we have an expression. What is that? Lambda MC at given concentration, molar conductance is equal to what? K, conductivity into 1000 by molarity. If you remember the expression, by using that you can find. Okay, and here in your data K is given. What is K given? K is given as 4.95 into 10 power minus 5. 4.95 into 10 power minus 5 Siemens centimeter square per mole it is given. Okay, next Siemens centimeter inverse. Siemens per centimeter is given. Then at infinite dilution it is given. At what is at infinite dilution? Lambda G, capital lambda 0 M of KCl is given. What is that? It is given as 390 Siemens centimeter square per mole. It is given. Okay, K is given. So now you can find that. What you can find? This you can find. Molarity is also given. Capital M. What is capital M? 0.00102. 0.00102. M is given. So now you can find lambda Cm. That is at this given concentration, what is molar conductivity? Molar conductance. So K into 1000 by M. So find K 4.95 into 10 power minus 5 into 1000 by 0.00102. That means 1.02 into how much? 123. 10 power minus 3, na? So 1000 by 10, now you find 1000 into 10 power minus 3 pi calculate 10 power plus 3 out. 10 cube 10 and it is 10 power minus 1 out. 4.95 into 1.02 into 10 power minus 1 will be lambda cm. Antena? It is almost 495. 49.5. Almost. 10 power minus 1 na kaya din 10 power 1 na. Plus 1 1 1. Find. See here, ఇది పై ఇది ఏమవుతుందమ్మా ఆల్మోస్ట్ ఎంత అవుతుంది సేమ్ వస్తుంది కదా you please calculate. See here, it is 4.95 into 10 power minus 5. ఇది 1000. 10 power minus 3 పైకి వెళ్తే 10 cube అవుతుంది. 10 cube into 10 cube 10 power 6. 10 power 6 into 10 power 4.95 into 10 by 1.02. Okay, so that is 49.5 by 1.02. 49.5 by 1.02 and nearly it is 49.5 or it is almost 48 something వస్తుంది కదా 48.52. So this is lambda c at given concentration. This is molar conductance. Okay, now what you should find? You should find dissociation constant, that is Ka. You should find what is Ka for your acetic acid, that is CH3COO minus into H plus by CH3COOH. ఇది ఎక్కడి నుండి వచ్చింది అనుకున్నారు already we learned that this under your ionic equilibrium. Okay, Ka or in terms of what is called alpha terms, how it can be written. So this is alpha square C by 1 minus alpha. Ka is equal to alpha square C by 1 minus alpha. So you want this Ka, but we don't know what is alpha. So already in our applications of Poison's law, we have learned how to find alpha. How to find alpha? Degree of dissociation alpha is equal to what? Lambda C m by lambda 0 m. So the ratio of molar conductance at given concentration to the molar conductance at infinite dilution is alpha. Got it? So here already we found that the given concentration. In the numerical itself it is given, that is lambda 0 m, that is at infinite dilution. When you take this ratio you will get alpha value. Then alpha square C by 1 minus alpha will give what? So Ka. So here C into 1 minus alpha actually, or you can write it as C minus alpha. C into 1 minus alpha. Or directly write like this. Alpha square C by 1 minus alpha. Then ఎంత అవుతుంది అప్పుడు అసలు ఇది ఎలా వచ్చిందో తెలుసు కదా మీకు ఐనిక్ ఈక్విలిబ్రియం లో చెప్పుకున్నాం మనం 1 0 0 ఇది C మోల్స్ అయితే ఆ ఆల్ఫా అనే డిగ్రీ ఆఫ్ డిసోసియేషన్ C into 1 minus alpha C alpha. So that is C square alpha square by C into 1 minus alpha. ఒక C cancel అయితే alpha square C by 1 minus alpha. Okay, now you find what is Ka. Also find what is alpha at given concentration molar conductance. What is at given concentration 48.52 divided by at infinite dilution. What is at infinite dilution? 390. 48.52 by 390 అంటే alpha వస్తుంది. ఎంత వస్తుంది alpha? How much you will get alpha value? 0.12. 0.12. This is degree of dissociation. Now find Ka. Actually, in your numerical, it is asked to find Ka value. What is Ka? Alpha square. That is 1.2 whole square into concentration. What is concentration? 0. 0.12. 0.12 whole square into 0.00102 divided by 1 minus 0.12. Okay, so if you find this value, then you will get Ka. ఎంత అవుతుంది చూద్దాం. So you must be thorough with the calculation part, or else you won't get the answer. Actually, okay, fine. I'll give So you take down it as 1.02 into 10 power minus 3. This is 0.12 whole square. 0.12, 144. 144 and 10,000. 0.0144 into 102 by 1 minus 0.12 means it is 0.78. 988. 88. Hmm. Is it understood? Hmm? రావట్లేదా 0.12 whole square. Answer ఎవరైనా చేశారా? Did you have you done anyone? Did you get the answer? So I'll give one what is called clue. Okay. Actually, if acetic acid is given in this way to find its dissociation constant by using this molar conductance at infinite dilution. Okay, you remember that in our ionic equilibrium while doing the pH values. Okay, we gave a Ka value of acetic acid and ammonium hydroxide. Actually, the Ka value for acetic acid and for ammonium hydroxide, it is 1.78 into 10 power minus 5. Okay, you must get that answer. Or in some books, it will be given as 1.8 into 10 power minus 5. That's why in your option, if 1.78 into 10 power minus 5 is there, just write it as 1.78. Okay, if it is given as 1.8, then write it as 10 power minus 5. But in this calculations, you will get this answer 1.78 into 10 power minus 5. Actually, this is fixed value because acid dissociation constant is constant at given temperature. So that's why Ka is a constant at 25 degrees Celsius because the temperature is not mentioned, it is room temperature, that is 25 degrees Celsius. Got it? Okay, that's why here you will get Ka value. If you simplify this, you will get the Ka value as 1.78 into 10 power minus 5. Okay, in your options, if it is given, that will be also correct answer. If it is not given. కాబట్టి మొత్తం ఇంకా పెద్ద క్యాలిక్యులేషన్స్ చేయాలా మేము మాకు సింప్లిఫికేషన్స్ ఓకే డోంట్ బాదర్ అబౌట్ దట్ జస్ట్ అప్లై సమ్ లాజిక్ Ka value is constant at given temperature only to make you confused all this data is given or if the values vary and that means temperature varies in your numerical if it is asked to find at 30 degrees Celsius then you have to do all these calculations so okay generally at room temperature it will be given that is at 25 degrees Celsius. If you find finally you will get this answer 1.78 into 10 power minus 5. Got it? Just to remember the method or we know they have given molarity, conductivity, then at infinite dilution. First you should find alpha value. For that you should find at the given concentration what is its molar conductance. For that we have an expression K into 1000 by m. Then alpha is equal to molar conductance at given concentration divided by molar conductance at infinite dilution. Okay, then you will get alpha value. K is equal to alpha square C by 1 minus alpha. Okay, directly by substituting you can get that. I think it is clear. Okay, next take down. The molar conductivity of 0.025 moles. The molar conductivity of 0.025 moles per liter methanoic acid is 0.025 moles per liter methanoic acid is 46.1 Siemens 46.1 Siemens centimeter square per mole. Now you take down this. At 30 degrees Celsius. At 30 degrees Celsius. Calculate its alpha and Ka. Will you find? Calculate its alpha and Ka. Actually, here methanoic acid is given. What do you mean by methanoic acid? What is its formula? That is HCOOH, formic acid. IUPAC name is methanoic acid. Whereas the IUPAC name of your acetic acid, CH3COOH, is ethanoic acid because there are two carbons. Okay, here methanoic acid. And it is given at 30 degrees Celsius. That means you have to follow all the way. Okay, do calculate what is Ka, alpha and Ka. Alpha is equal to what is called molar conductance at given concentration by molar conductance at infinite dilution. Ka is equal to alpha square C by 1 minus alpha. This is common for mono basic weak acids. Okay. Next, first you find lambda C at given concentration. Lambda MC. Okay, how it is? K into 1000 by M. Already procedure you have. K is given. What is K given? 46 point. Sorry. 46.1. No, actually K is not given. Here what is given? Molar conductivity is given. K is not given. So here what is given? Molar conductivity. That is lambda M at given concentration is given. So lambda M at given concentration is nothing but what? The molar conductivity of 0.025 molars per liter methanoic acid is 46.1 Siemens. Okay. But take down. Some more here given in data. That is lambda 0, small letter lambda 0 of H plus ion. Small letter lambda 0 of H plus ion is 349.6 Siemens centimeter square per mole. Siemens centimeter square per mole. Then lambda 0 of HCOO minus HCOO minus is equal to 54.6 Siemens centimeter square per mole. Now you find. So already it is given. Lambda Cm is given. Molar conductivity at given concentration is given as how much? Lambda Cm is given in your numerical itself. Okay, what is that? Lambda Cm 46.1. Okay. Next here lambda 0m is not given. That you should find. How can you find? By using your Kohlrausch law. So according to Kohlrausch law, the sum of these ionic conductances is nothing but molar conductance at infinite dilution. So that means lambda 0m of formic acid HCOOH is equal to this plus this. And out the 12, 5 plus 9, 14, 5, 6 plus 4, 10, 404.2 Siemens centimeter square per mole. Find alpha, then Ka. So here not that expression. K is equal to lambda M is equal to K into 1000 by M. Here by using this you can find alpha because already it is given. Only to make you confused, the molar concentration is given. అంటే ఇక్కడ C కావాలి కాబట్టి ఇచ్చుంటాడు Ka. ఓకే ఆల్ఫా ఎంత అవుతుంది అప్పుడు 46.1 by lambda 0m, that is 404.2. 46.1 by 404.2. We give alpha value. So this is 461 by 4042. 0.114. Okay. 0.114. This is alpha. And then find Ka. Ka is equal to alpha square C by 1 minus alpha. That is 0.114 whole square into C. It is given as 0. I think 0.025. 0.025 by 1 minus 0.11. So simplifications ఎవరు బాగా చేస్తే వాళ్ళకి simplify the answer. I think it is understood. Hmm? Very good. 3.6 into 10 power minus, yeah, 3.6 into 10 power minus 4. Okay, 0.114 whole square into 0.025 by 1 minus 0.114. That is 3.6 into 10 power minus 4. Okay, so this is how to find Ka when directly conductivity and molar concentration are given, or at infinite dilution ionic conductances are given. Okay, next move to next. I think I explained regarding electrolysis. Okay, next Faraday's laws. Take down solution of copper sulfate. Solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. With a current of 1.5 amperes. What is the mass of copper deposited? What is the mass of copper deposited at the cathode? What is the mass of copper deposited at the cathode? Okay. So here you have to find what is the mass of the cathode deposited. Okay. So how can you find the mass of copper deposited? By using your Faraday's first law, you can find. Okay. So copper sulfate aqueous solution is electrolyzed. That is CuSO for aqueous. So then it dissociates into Cu2 plus plus SO4 2 minus. Okay. Later these Cu2 plus ions, okay, they are reduced to copper metal at the cathode. So now you have to find how much of copper will be deposited on the electrolysis of copper sulfate solution. Now to deposit, okay, so 1 gram equivalent of copper, how much electricity is required? 2 moles of electricity, 2 moles of electron. That is 2 Faradays are required. Okay, to deposit 1 equivalent. So here you can write it as mass is equal to ECT divided by 1 Faraday, that is 96,500 coulomb. So you can have this expression to find mass in general. Okay, so now mass is equal to E means equivalence. What is called it? Electrochemical equivalent. So what is electrochemical equivalent of copper? So what is equivalent of copper? Equivalent means molecular weight by or atomic weight by 2. Okay, because its valency is 2 for metals. Equivalent weight is equal to atomic weight by 2. What is atomic weight of copper? 63 grams. What is its valency? 2. 63 by 2 means it is 2, 2 3 is 6, 2 1s are 2. Okay, 31.5 grams. E is 31.5 grams. C, I think it is given in your expression. Okay, what is given? 1.5 amperes for 10 minutes. C or I, you can write it as I or C. C means current in amperes. Okay, so now 31.5 into I, that is how many amperes is given here? 1.5 amperes into T. How much time it is paused? 10 minutes. Okay, that but you should take in terms of second. That is 10 into 60 divided by 96,500. Because for 1 Faraday, you will get that much. What is the amount of copper deposited for 1 Faraday you have to do. So that's why mass is equal to E into I into T by 96,500. So then if you find this, what will you get? It is given, it is we know, okay, because atomic weight by valency is nothing but it's electrochemical equivalent into 60 by 96,500. So what is the mass deposited? How much mass of copper is deposited? Calculate how much you will get. 60 into 10, 600. 600 into 1.5 is 600, 900. 900 into 31.5 by 96,500. Just 10% the mass of the copper deposited. Almost it is equal to 0. 0.26 grams it seems if you find. Okay, so this is how to find. For example, if here the gas is given, the gas amount of the gas liberated, then here you should take in terms of electrochemical equivalent, you should take a volume equivalent, VE. Okay. Next, take down one more question. What is the ratio of silver and aluminium? What is the ratio of silver and aluminium deposited at the respective cathodes when the same amount of current is passed through aqueous silver nitrate and aluminum sulfate solutions. Find the ratio of amounts of silver and aluminum deposited at respective cathodes when the same amount of current is passed through silver nitrate and aluminum sulfate solutions. Okay. So here, when you pass some amount of electricity through silver nitrate, first it dissociates into Az plus and NO3 minus. Okay. So now Az plus to get deposited as silver, it requires 1 Faraday, 1 mole of electrons. That is 1 Faraday of electrons is required. So that means what is the equivalent weight of silver? Atomic weight by valency. Okay. Atomic weight of silver is 108 by 1. Okay, valency 1. Atomic weight of silver is 108 gram. Similarly, you are passing same amount of electricity through aluminum sulfate. So first it dissociates into 2 Al3 plus ion and 3 SO4 2 minus ion. Now to deposit Al3 plus ions as aluminum metal, it requires 3 Faradays of electricity. Okay, that means what is the equivalent weight of aluminum? Aluminum equivalent weight is equal to what? Atomic weight by valency. What is the atomic weight of aluminum? 27 grams by 3. Valency is 3 na? 3. So the 27 by 3 means it is 9 equivalent weight. So here these two are the different electrolytes. They are connected in series. Through them, if same amount of current is passed through these two electrolytes connected in series, what is your Faraday's second law? The amount of the substances deposited at different electrodes are in the ratio of their equivalent masses. So that means you have to find mass ratio. That is mass of silver by mass of aluminum ratio you have to find. Okay. So mass of silver by mass of aluminum is equal to what? Equivalent weight of silver by equivalent weight of aluminum, because always this ratio is in the ratio of their equivalent weight. That is only your second what is called second Faraday's second law. కాబట్టి ఏమవుతున్నప్పుడు ఈక్వలెంట్ weight of silver ఎంత ఉంది 108 grams. What is the equivalent weight of aluminum? 9 108 by 9. So that is this ratio. అంటే ఎంత అవుతుంది 12:1. Got it? Okay. In this way, the question may appear according to your second law. Okay. Next. We had to move to Nernst equation. Kada? Next. Nernst equation. Take down the question. Calculate E cell of a galvanic cell. Calculate E cell of the following galvanic cell. You take down the galvanic cell I think you have learned how to write the galvanic cell. Okay. Take down the galvanic cell, representation of cell. Mg solid, single line, Mg2 plus, within small brackets 0.13 molar, 0.13 molar, two parallel lines, Ag plus, Az plus, within brackets 0.0001 molar, 0.0001 molar, that is 1 into 10 power minus 4. Single line, Ag solid, if the E0 of the cell is, plus 3.17 volts, okay. So here how to find E of the cell? Calculate E cell. Okay, calculate E cell if E0 cell is plus 3.17 volts. So how to calculate? Actually, here what is the cell reaction given? What is the cell given? Cell emit చెప్పండి ఒకసారి. What is the cell given? That is what is called, where is that cell? Mg2 plus, salt bridge, Ag plus, Ag given. So first you have to write the cell reaction for this. Okay. How can you write the cell reaction here? So Mg2 plus na. So that's why what is the cell reaction? Mg plus 2Ag plus, because Mg is converted into Mg2 plus, Ag plus is converted into Ag. So that's why Mg plus 2Ag plus giving rise to Mg2 plus 2Ag. This is the reaction. Okay. So here you consider this as what is called at equilibrium, because we don't know other things. Only we have E0 of the cell. What do you find? You should find E cell. Okay. So that's why what is E cell? E cell is equal to E0 cell minus, you have an expression. What is that expression? E0 of the cell minus 0.059 by n log Q. What is log Q? Log Q is nothing but reaction quotient, because if it is not at equilibrium, then you can consider it as log Q. If it is at equilibrium, then you can consider it as log K. Okay. Now you have to find E cell. E cell is equal to E0 cell is given. What is that E0 cell? 0.13. E0 cell, sorry. E0 cell is 3.17 minus 0.059 by n. N is number of electrons gained or lost. So here how many electrons are gained? 2Ag plus means 2 plus. To become 2Ag, it has to gain 2 electrons. So that's why by 2. Okay. Then log base 10. So here Q means what? Q means molar concentration of Mg2 plus solid. Always you should consider it as unit concentration. Okay. By molar concentration of Mg, always unit concentration, by 2 molar concentration of Ag whole square. అంతే కదా, log base 10. So ఈ రెండింటి concentrations వాళ్ళే ఇచ్చారు మీకు. Got it or not? So what is reaction quotient for this? Q is equal to Mg2 plus into Ag. Okay, Ag solid actually, by Mg solid into Ag plus whole square. Okay, 2 ఉంది కాబట్టి. అయితే ఇది యూనిట్ కాన్సంట్రేషన్ అనుకుంటాం కాబట్టి రెండు పోతాయి. పోతే మనకి మిగిలిన ఏంటి mg2 plus by ag plus whole square. So log base 10 mg2 plus concentration, how much it is given? Magnesium concentration, how much it is given? mg2 plus ion 0 bracket లో రాసుకున్నారు 0.13 by ag plus, how much it is given? ag plus 0.001, that is 1 into 10 power minus 4 3 కదా ఉండేది 0.0001 1 into 10 power minus 4 whole square. Antena? Now you will get what is E cell. Is it understood? Only here E0 cell is given and concentrations are given. But to find E cell, now you have to write first this equation. Then you should write what is log Q. Okay, because Q you can get from the concentrations. Okay, so then you can write this and you will get this. What you will get the answer? 3.17 minus 0.059 by 2 log base 10 0.13 by 1 into 10 power minus 4 whole square. ఎంత అవుతుంది అప్పుడు ఇది 1 into 10 power minus 8 అవుతుంది కదా 1 into 10 power minus 8 అంటే log base 10 1 by 1 into 10 power minus 8 అంటే log base 10 10 power 8 అవుతుందా అంతే కదా టేక్ క్యాలిక్యులేట్ log base 10 0.13 by 1 into 10 power minus 8. So పైకి వెళ్తే ప్లస్ 8 అవుతుంది అంటే log base 10 0.13 into 10 power 8. 0.13 into log base 10 0.13 into 10 power 8. 0.059 by 2. ఈ log base 10 అలానే ఉంటుంది. So 0.13 into 10 power 8 అవుతుంది ఇది కింద మైనస్ 8 కదా పైకి వెళ్తే 10 power 8 అవుతుంది 0.13 into 10 power 8 దానికి లాగ్ వాల్యూ మీరు కనుక్కోవాలి మొత్తం చేస్తే యూ విల్ గెట్ వాట్ ఈస్ ఈ సెల్ ఓకే సో ఇఫ్ యూ ఫైండ్ సో హియర్ E0 cell is given in terms of volts 3.17 volts కదా ఇచ్చారు so that's why you will get E cell also in terms of volts. I think if you find the options ఇచ్చారు చూడండి మీరు ఒకసారి చెక్ చేసుకోండి 2y option A is 2.96 option B 3.96 option B 4 2.96 3.96 4 and option D 1.96 1.96 okay if you find then you will get the answer. Next change ఇంకొకటి ఇది just you can do easily calculate the potential of hydrogen electrode in contact with a solution whose pH is 10 whose pH is 10 will you find potential of the hydrogen electrode that means half cell for half cell you have to find the potential of the electrode hydrogen electrode how to find it half reaction half reaction so half is H plus H2 is equal to what H plus H2 is equal to what this is minus 0.059 by 2 log actually here also you can write it as log Q okay now how can you find it So here what is the given equation actually? Calculate the potential of hydrogen electrode in contact with a solution whose pH is 10 అన్నాడు. అంటే H plus concentration ఇచ్చినట్టే కదా, pH 10 అనుకోండి. What is H plus concentration? The H plus concentration is 10 power minus 10. అంతే కదా, pH is 10 means H plus concentration is 10 power minus 10. So here hydrogen gas is liberated. Okay. So but how much hydrogen gas is liberated is not given. Okay. But you have this. What is H plus to H2 means what is the equation? 2H plus 2 electrons giving rise to hydrogen gas. That is here you are getting 1 mole of hydrogen gas. You are getting 1 mole of hydrogen gas. Okay. Then what is the valency? Valency will be 2 because for H plus M 1 electron, for 2H plus M 2 electron. So that means how many electrons are gained here? 2 electrons. Okay. N value is 2. 0.059 by N log Q kada. N ante ikkada 2. Kabatti ippudu em avutundi then log Q you have to find. Log Q. So here you are getting the hydrogen gas. 1 mole of hydrogen gas. So 1 mole of hydrogen gas ante pressure is will be 1 atmosphere. Okay. So then what you will have? So 0 minus 0.059 by 2 log Q means log H2 by H plus ion concentration. Log Q ante enti ikkada log base 10 H2 by H plus concentration. ante kada H2 by H plus concentration whole square because 2H plus. So here this is minus 0.059 by 2 log base 10 hydrogen gas. Okay. Gas ki concentration terms మీరు consider చేయలేరు. Okay. కాబట్టి ఇక్కడ మనం pressure తీసుకున్నాం అనుకోండి. You consider it as 1 atmosphere. 1 by H plus concentration whole square. What is H plus concentration? 10 power minus 10. అంటే 10 power minus 10 whole square. అంటే 10 power minus 20 అవుతుంది ఇది. So 1 by 10 power minus 20 అంటే పైకి వెళ్తే 10 to the power 20 అవుతుంది. ఎంత అవుతుంది అప్పుడు చెప్పండి? 0.059 by 2 log base 10 to the power 20 minus, very good, minus 0.59 volts. Okay. I think it is understood. So this next. What is time? 10:05. There are three. There are Gibbs energy మీద కావాలి కదా. Better to take down. Try to do, or else we'll discuss. Okay. Calculate. Take down the 3 questions and try to do at home. Calculate the equilibrium constant for the reaction. Make it fast because physics sir is waiting. It's in. Calculate the equilibrium constant for the reaction Cu solid plus 2Ag plus aqueous. Cu solid plus 2Ag plus aqueous. Reversible arrow. Reversible arrow. Cu2 plus aqueous. Cu2 plus aqueous plus 2Ag solid. Plus 2Ag solid. E0 of the cell is plus 0.46 volts. E0 of the cell is plus 0.46 volts. Okay. Next question. The cell in which the following reaction occurs. The cell in which the following reaction occurs. 2Fe3 plus aqueous. 2Fe3 plus aqueous plus 2I minus aqueous. 2Fe3 plus aqueous plus 2I minus aqueous giving rise to 2Fe2 plus aqueous. 2Fe2 plus aqueous plus I2 solid. Plus I2 solid. Has as E0 cell is equal to E0 cell is equal to 0.236 volts. 0.236 volts at 298 Kelvin. At 298 Kelvin. Calculate standard Gibbs free energy, that is delta G0. Calculate standard Gibbs free energy, delta G0, and equilibrium constant. So already I gave expression for this. Delta G0 is equal to what? Minus NF E0. Minus NF E0. N means number of electrons gained or lost. Okay. F means 96,500. E0 already given. Then you have to, by using that, you can easily find what is K also. Next, take down one more. In the button cells widely used in watches, and other devices, the following reaction takes place. Take down the reaction. ZNS. ZN solid, sorry, ZNS means zinc solid. Zinc solid plus Ag2O. Zinc solid plus Ag2O. Solid. Plus H2O liquid. Giving rise to Zn2 plus liquid. plus 2 Ag solid. Zn2 plus liquid plus 2 Ag solid plus 2 OH minus aqueous. Determine delta G0. Determine delta Z0 and E0 of the cell. Given E0 of Zn single line Zn2 plus is given E0 of Zn2 plus is minus 0.76. And E0 of Ag and E0 of Az plus Az. E0 of Az plus Az is plus 0.34 volts. Okay. So if you find these three numericals, with that we can conclude what is called the numericals of our electrochemistry also. Okay. So this week on Sunday, you will have the test of complete physical chemistry syllabus, which we have explained. Okay. So first year and second year topics other than solid state in second year, then atomic structure and thermodynamics on first year. All the remaining topics are there for your syllabus. Okay. So tomorrow directly we will do numericals of atomic structure. Tomorrow and day after tomorrow. Theory is not that much important regarding atomic structure. So we can complete
Good morning, everybody. We'll continue with the problems on wave motion. First question. If x equal to a sine of omega t plus pi by 6 and x dash equal to a cos omega t represents two plane progressive waves. If x equal to a sine omega t plus pi by 6 and x dash equal to a cos omega t represents two plane progressive waves, then find the phase difference between the two waves. Then find the phase difference between the two waves. So the phase difference between the two waves we can find. The second wave I'm writing it as x dash is written as a sine of omega t plus pi by 2, and first wave is a sine of omega t plus pi by 6. So if you compare the two plane progressive waves, the two plane progressive waves, they have an initial phase of this one. First wave has initial phase of pi by 6. Second wave has an initial phase of pi by 2, and the phase difference is equal to mod of pi by 2 minus pi by 6. So this is the phase difference. This is the first answer. So pi by 2 minus pi by 6. So the phase difference is pi by 3. What we have done here, two waves we have observed. The first wave a sine of omega t plus pi by 6. The second wave x dash equal to a cos of omega t. And we have changed the second wave form in terms of sine function. And we compared both, we have observed both the waves x and x dash. On comparison of x and x dash, there is a initial phases for the two waves. The initial phase for the first wave is pi by 6. The initial phase for the second wave is pi by 2. And if you do the difference of the initial phase of phi 2 minus phi 1 or phi 1 minus phi 2, then we can calculate the phase difference between the two waves. Next question. Wave velocity for the next question. How much it is? 10,000. Yeah, second question I'll read. First, if you have done with first, then second question I'll read. So coming to the second question. Second one. The phase difference between 2 points is 1.25 centimeters. The phase difference between 2 points of a wave, the phase difference between the 2 points of a wave, progressive wave, is 1.25 centimeters. Path difference between 2 points of a wave is 1.25 centimeters. And phase difference between the 2 points is pi by 4. Phase difference between 2 points is pi by 4. frequency of the wave is 1000 hertz. Frequency of the wave is 1000 hertz. Then find the wave velocity. Frequency of the wave is 1000 hertz. Then find the wave velocity. This is the question. Second one. So given a path difference delta x, the path difference between 2 points in a wave, 2 particles of a wave, path difference is 1.25 centimeters, and phase difference is given as pi by 4. Phase difference is pi by 4, and frequency of the wave given 1000 hertz. Frequency 1000 hertz. Find the wave velocity. So the relation is phase difference delta phi is equal to phase difference delta phi equal to 2 pi by lambda times of path difference. Phase difference delta phi is equal to 2 pi by lambda times of the path difference. You can substitute the values in this and find lambda. After finding lambda, you will get v is equal to wave velocity v is equal to f into lambda. So after finding lambda, you can substitute frequency and lambda. You can get the wave velocity. You can calculate. So you can substitute the wavelength in v equal to f lambda. Frequency is 1000 hertz. So pi by 4 equal to 2 pi by lambda times of delta x. That is I think some of you forgot to convert this centimeters 1.25 centimeters into meter, it seems. That is why you are getting 1000 meter per second. Check once, check the calculation. From this, you can calculate the lambda, and after getting lambda, you can substitute here and multiply with 1000. Frequency into lambda. Now you will get the wave velocity correctly. Now you can give the answer. After converting centimeters into meters. Yes, 100 is correct. Yes, Akshita correct. Aditi correct. Kaushik correct answer. Dinesh correct. We'll proceed to the next question. Yes, Shrestha correct. Yes, correct. Next one. Next question. Yeah, sorry for the inconvenience. Wi-Fi has been disconnected. I hope I'm audible now. Are you able to hear me? Okay. So here, this is the string. Its linear density is mu, and the tension in the string T. Tension you have to find out. So V is equal to under root of T by mu, and V is a coefficient of T by coefficient of X. The wave speed is coefficient of T by coefficient of X. So here I have given you the X and Y are so the units which we take up for measuring X and Y. So as per that you can proceed. X and Y are in meters and time in seconds. So this wave velocity V is a T coefficient 30 and X coefficient 1. So V is a coefficient of T by coefficient of X. So velocity, wave velocity you get 30 meter per second. This wave velocity you can substitute here and calculate the tension. Linear density is given to you. So what you will get here? 30 square equal to tension in the string by linear density 10 power minus 4. So you can get the tension in the string you can find out. So T tension you can find out. So you can give the answer. Zero 0.9, 0.09. But the required answer is you check once again. The required answer is 0.09. I think that should be the correct answer. You have to check once. 0.09. Yeah, correct. Anaga, correct. Aditi, correct. Yes, remaining people, you can give the answer. Okay, Kaushik. Yeah, Prithvi, correct. Shreya, 0.09, correct. Shreya, correct. And next question. So, tension, if you calculate, you get 0.09 Newton is the tension of the calculation. Next question. Next question. If the maximum speed, if the maximum speed of a particle, if the maximum speed of a particle on a traveling wave, if the maximum speed of a particle on a traveling wave is given as if the maximum speed of a particle on a traveling wave is given as V naught, if the maximum speed of a particle on a traveling wave is V naught, then find the speed of the particle. Then find the speed of the particle. Then find the speed of the particle when displacement is half of its maximum value. When displacement is half of its maximum value. When displacement is half of its maximum value, you find out the particle velocity. At this condition, under this condition, when displacement y is equal to a by 2, under this condition, you calculate the particle velocity. So just see the question. Any answers? Any answers? So here the given condition is like this: y equal to a sin of kx minus omega t plus phi, and velocity, particle velocity, if you calculate a omega cos of kx minus omega t plus phi. But the given condition is y equal to a by 2. Displacement, when displacement is half of the amplitude, that means in this equation, if you substitute a by 2 equal to a sin of kx minus omega t plus phi. So here we get 1 by 2, so pi by 6. Kx minus omega t plus phi. This you will get it as pi by 6. And you can keep this value aside. You can keep this value. You can use it for calculating the particle velocity. Means when we substitute the condition y is equal to a by 2, we got this condition. With the help of this condition, we have to find out particle velocity. So particle velocity is v particle is a omega cos of kx minus omega t plus. So a omega means maximum particle velocity. A omega is a maximum particle velocity, that is v naught. So a omega, I am writing it as v naught. A omega is written as v naught into cos of kx minus omega t plus phi. Kx minus omega t plus phi is already pi by 6. So cos pi by 6. So now you will get the answer. You can just see one. So any answers? Yeah. Yes. Yeah, definitely. Definitely, Shreya. Oh, you mean to say I have to allow you to solve a, you mean to say? I didn't get you. Okay, I understood. Means I am calculating, instead of that I have to allow you people to calculate. Okay. Sure, definitely. Definitely. Sure. So maximum particle velocity is v naught, and particle velocity is a omega cos of kx minus omega t. And if we substituted a condition y is equal to a by 2, and substituting the condition in place of y is equal to a by 2, a by 2 equal to a sin of kx minus omega t plus phi, and a gets cancelled on both sides. Sin of this whole value is equal to 1 by 2, that is 30 degrees, pi by 6. Kx minus omega t plus phi is pi by 6. So this after substituting the condition, this kx minus omega t plus phi equal to pi by 6. This one we'll use it to find out the particle velocity. Why? Because we have to find out the particle velocity at this y equal to a by 2 condition. At y equal to a by 2 condition, we got this. So using this, v particle is a omega cos of something. So a omega is maximum particle velocity. Maximum particle velocity is written as v naught, and v naught into cos pi by 6, since kx minus omega t plus phi is pi by 6. So cos pi by 6. Now the required answer is root 3 v naught by 2. Root 3 v naught by 2 is the particle velocity. So the answer, required answer is root 3 v naught by 2. Next one. Next question. Next question. Is this visible? All of you? Next question. Where? Yeah. A copper wire is held at two ends. A copper wire is held at the two ends by a rigid support. A copper wire is held at the two ends by a rigid support at a temperature of 30 degrees Celsius. When the string and surroundings temperature, when the string is maintained at a temperature of 30 degrees Celsius, the wire is having zero tension. Now, the wire is having zero tension now. Means the wire is loose, slack, it has no tension now at 30 degrees Celsius. If the temperature is decreased to 10 degrees Celsius, if the temperature is decreased to 10 degrees Celsius, if the temperature is decreased to 10 degrees Celsius, then find the speed of transverse wave. If the temperature is decreased to 10 degrees Celsius, then find the speed of transverse wave. Find the speed of transverse wave given alpha linear expansion coefficient, given alpha linear expansion coefficient of wire. Next, y is the Young's modulus. Y is the Young's modulus of the wire. Alpha linear expansion coefficient, y Young's modulus of the wire. Rho is the density. Rho is the density of the wire. Rho is the density of the wire. So you have to calculate the speed of the transverse wave along this string. So find out the speed of transverse wave and make use of these given quantities: alpha linear expansion coefficient, y Young's modulus, rho density of the string. Make use of these quantities. So in this question, you have to find out the speed of the transverse wave, and as the transverse wave is created as it travels, the speed of the transverse wave pulse we have to find out. The condition is there is a temperature difference. There is a temperature difference. Initially, when the string was maintained at 30 degrees Celsius, there was no tension in the string. And when the temperature is reduced from 30 to 10 degrees Celsius, the string contracts and it becomes tight. Tension arises in the string. And as the tension arises in the string, the transverse wave can travel through the string, across the length of the string. It can travel. Yeah, any answers? Young's modulus of the wire Y is a force tension. There is a force across the wire. Tension into length of the wire by A into elongation, A delta L, Young's modulus. From this, we can calculate T by A value, we can get T by A, tension divided by area. T by A value is T by A equal to Y delta L by L. T by A is Y delta L by L, you can substitute, you can get the answer. That's all. Root of what is the answer? Root of y into alpha by density. Yeah? Let me check once. So v equal to under root of T by A is Y delta L by L. This is a T by A. And the density is over there. So already density rho is given to you. Rho is a given value. Young's modulus is a given value. Next, delta L, the change in length, the delta L is y into delta L is L alpha delta T by L rho. So the answer is y alpha delta T by rho. Length gets cancelled. Delta L I have replaced with L alpha delta T. So y into alpha into delta T by rho. The speed of the transverse wave in terms of y alpha rho. And delta T we know. So how much it is? Delta T is 30 minus 10. 20 into alpha into y by rho. 20 into alpha into y by rho. Now I'll check the answer, sir. I think you have answered root of y into delta into alpha into t by density. That is okay. Yes, correct. Under root of 20y 20 under root of 20y alpha by rho. It should be root of 20y into alpha by density. Yes, correct. Next one. I hope it is done. The answer is done. I hope you have got the answer. And I have calculated here. It is 20 into alpha into y by rho. The final answer. Okay, na? Yeah. Okay, sir. Next question. Next question. Next question, the diagram related to the next question. Yeah. A uniform rope. Next question. A uniform rope of length. A uniform rope of length 12 meters. A uniform rope of length 12 meters and mass 6 kg. A uniform rope of length 12 meters and mass 6 kg hangs vertically from a rigid support. A block of mass 2 kg is attached. A block of mass 2 kg is attached. A block of mass 2 kg is attached to the end of the rope. A block of mass 2 kg is attached to the end of the rope. A wave pulse of wavelength. A wave pulse of wavelength. A wave pulse 0.6 meters is produced. A wave pulse of wavelength 0.06. A wave pulse of wavelength 0.06 meters is produced at the lower end. 0.06 meters is produced at the lower end of the rope. This is the wavelength of the wave pulse as it is produced at the bottommost point. Now, find the wavelength of the wave pulse. Find the wavelength of the wave pulse as it travels. Find the wavelength of the wave pulse as it travels. Find the wavelength of the wave pulse as it travels the top of the rope, as it reaches the top of the rope. Find the wavelength of the wave pulse as it reaches the top of the rope. So that means lambda dash here, lambda dash we have to find out. Lambda here at the bottommost point when the wave pulse was created, wavelength is 0.06 meters. And when it reaches to the topmost point of the rope, what is the wavelength? You have to find out the lambda dash. You can calculate. Yeah, any answers? .12. Done. So any answers? Okay, correct, ma. Correct answer. Right. Correct answer. So here, in this question, the wavelength of the wave pulse traveling across the vertical string, the wavelength is proportional to root of square root of tension, lambda proportional to root t. So lambda 1 by lambda 2 is under root of t1 by t2. So as per that, we substituted the one lambda value and one more we have to find, and the two tensions we calculated. Tension at the lowest point. The tension at the lowest point is the weight acting below that point. So that is 2G, and tension at the highest point is nothing but the weight, total weight acting below this point. The total weight below this point is 2G and 6G. That is total weight of the rope and weight of the block. So 6G plus 2G, total 8G is the total weight below this point. So that is nothing but tension here. Total weight below this point is 2G. That is equal to tension. So tensions we substituted, one lambda value we substituted, and unknown lambda at the highest point of the rope, the lambda we calculated, it is the answer is 0.12 meters is the wavelength of the wave pulse at the topmost point of the rope. Next question. Next one. Right down. A wave of frequency 500 hertz, a wave of frequency 500 hertz has a velocity 360 has a velocity 360. A wave of frequency 500 hertz has a velocity 360 meter per second. Then find the distance. Between two nearest points. Then find the distance between two nearest points. Which are 60 degrees out of phase. Then find the distance between two nearest points which are 60 degrees out of phase. So you have to calculate the distance between 2 points. So in a medium, the distance between these 2 points, which are having a phase difference of 60 degrees. So any 2 points, suppose they are having, if you locate 2 points and they are having a phase difference of suppose 60 degrees, then this distance of separation you have to find. This delta x you have to find. Means, for example, I'm showing the 2 points A and B. That doesn't mean that these 2 points A and B should be here only. It is not like that. So these 2 points of the wave, somewhere at 2 different positions they are located, and the separation between these 2 points we have to find out. provided the phase difference between these two particles are given to you. Now we can give the separation. What is the answer? 3/50, yeah, 3/50. And can you give in terms of centimeters and meters both? 0.12 means I think it is in terms of meters. I think 0.06 or no, 0.06 not correct. Check once. And in meters or in centimeters, you please specify. 0.12, I think it is in meters. So can I get the answer in terms of centimeters? Yes, yes. So the required answer is 12 centimeters or 0.12. So here the relation between path difference and phase difference we know. That is phase difference is equal to 2 pi by lambda times of the path difference, and this path difference is the separation between the horizontal separation between 2 points A and B. Now phase difference is 60 degrees. That is equal to 2 pi by lambda. Lambda is V is equal to F lambda. Lambda is V by F. So V by F means 360 by 500. So it is into delta x. Delta x we have to find out. So now you can give the delta x value. All our SI units we are substituting. So we'll get separation in meters we'll get. So now we can conclude with the value, the separation, the correct value you can give. So here in place of wavelength, lambda equal to wave velocity 360 by frequency 500 we substituted. So what is the answer? Final answer you can conclude once. 12 centimeters. Okay, done, correct. In centimeters I require. In meters also it is okay. 12 centimeters correct. 12 centimeters is the correct answer. Or 0.12 meters is correct answer. Okay. Yes. Correct. In these cases, if an organ pipe which is open on both sides and an organ pipe which is open only at one side, only at one end, and the organ pipe open at both ends, the difference are, if you can see one thing. If length of the L is the length of the organ pipe, now here this is the fundamental frequency. Fundamental frequency is F naught is say here length L of the pipe is equal to lambda by 4. L is equal to lambda by 4 and wavelength is 4L. So V by frequency F is equal to V by lambda, that is fundamental frequency is V by 4L. This is a fundamental frequency. Next, if it is for the open organ pipe, the length is L equal to lambda by 4 plus lambda by 4. That is L is equal to 2 lambda by 4 and lambda by 2. L is equal to lambda by 2 and L is equal to 2L. Lambda is equal to 2L. So fundamental frequency is V by lambda and fundamental frequency is V by lambda. I am writing it as so lambda is 2L. So what is the difference? Fundamental frequency of a closed organ pipe at one end, closed at one end. The closed organ pipe frequency and open organ pipe, that is the two ends of the pipe are open. So in this case, the fundamental frequency and their corresponding first overtone frequency, second overtone frequency is basing upon that we have to solve some problems basing upon fundamental first overtone frequency, second overtone frequency, basing upon that. So write down. A closed organ pipe, a closed organ pipe, a closed organ pipe, and an open organ pipe. A closed organ pipe and an open organ pipe have their first overtones. Have their first overtones. Have their first overtones identical. Have their first overtones identical. Means what? Closed organ pipe and open organ pipe, they are having their first overtones identical in frequency. Identical in frequency. Then find the ratio of their lengths. Then find the ratio of their lengths. So what you have to find out? You have to find out the ratio of their lengths. The closed organ pipe and open organ pipe lengths ratio you have to find out. So if you can, so you can find out the ratio. Given condition, you have to see properly. The given condition is first overtones of closed organ pipe and open organ pipe are identical in frequency. This is the condition. Using this condition, you calculate the lengths of and both the organ pipes, so closed and open organ pipes, their frequencies are same. So you can keep that particular thing in mind. Next, coming to the first overtone frequency. So the first overtone frequency will be like this. Here, L is equal to, for this first order frequency, length L is equal to lambda by 2 plus lambda by 4, and 3 lambda by 4 is the length, and lambda is 4L by 3. The wavelength in first order frequency for closed, lambda is 4L by 3, and frequency is frequency first order on V by lambda, that is V by lambda is 4L by 3. So that means 3V by 4L for open organ pipe, 3V by 4L, and for if it is for closed organ pipe, first organ frequency 3V by 4L, and for open organ pipe, the first organ frequency you will get it as 2V by 2L. You will get V by 2L. Next one is next frequency you will get it as 2V by 2L for this next higher frequency. So as per the given condition, the two pipes are closed and open, their first order frequencies are equal. They are identical in frequency. So these two frequencies, first order frequencies, you equate and then calculate the ratio of their lengths. You calculate, you can give the answer. What is the answer? Three is to 1:2. Next answer 3:4, 3:2. Okay. So, but actually, the required answer, the correct answer is 3:4 is the correct answer, ma. We require the ratio of L closed by L open. The required answer, the correct answer is 3:4. Okay, ma. Correct. Correct answer. Yes, any other answers? 3:4, correct. Yeah, definitely. Definitely. See here. 3V by 4L is equal to, next 2V by 2L. V gets cancelled. So 3 by 4 into L closed is equal to 1 by L open. So now LC by L, how much it is? L closed by L open. So this ratio you can calculate. So 3L naught is equal to 4 into L closed, and LC by L naught is 3:4. I hope you understand why we are equating these two. So this 3V by 4L for closed pipe, it is the first order frequency, and 2V by 2L for open pipe, it is also the first order frequency for open pipe. Open pipe means open at both ends. Closed pipe means open at one end. So we equate these two, and if we do the ratios of the lengths, L closed by L open is 3:4. This is the answer. I hope you have got. Got it? Okay, na? We'll continue in the next class. Prepare for the weekend examination. We'll continue with some more problems in the next class. Thank you.
Yes. Yesterday we have done the hyperbola part. Today we are taking up the 3D geometry part. The 3D geometry part consists of the coordinates, direction ratios and cosines, plane and the line. So today we will try to complete the coordinates along with some part of the data DSS. The first question in the coordinates, yes, A is equal to 4, 3, 5 and B is equal to 0, -2, 2 and C is equal to 3, 2, 1 or 3 vertices of triangle ABC, then point where bisector of angle BAC meets BC. Yes, 15 by 8, 4 by 8, 11 by 8, 12 by 7, 2 by 7, 10 by 7, 9 by 5, 2 by 5, 7 by 5, 3 by 2, 0, 3 by 2. Give a reading to the question. Give a reading to the question. Just in a minute, I will tell you the solution. Yes. Now, the answer goes like this. The solution goes like this. Observe, if this is a triangle, ABC and the bisector of the vertical angle. The bisector of the vertical angle divides the base. Before the advent of the bisector, this BC is only 1. Now, when you draw the bisector, when the bisector meets BC, it is dividing the BC in the ratio of BD is to DC. The vertical angular theorem says that BD is to DC is same as AB is to AC. Okay? So, what you have to find out? AB and the AC distances you have to find out. Can you find out AB and AC distances? Find out AB and AC distances. AB and AC distances you find out. A value is 4, 3, 5 and B value is 0, -2, 2 and C value is 3, 2, 1. How much is AB under root 4 minus 0, 16, 3 plus 2 square, 25, 5 minus 2, 9. So how much is this? AB is equal to root 50. Root 50 is written as 5 root 2. 5 root 2. Now, AC can be taken up. AC is how much? 1 plus 16, which is root 18. Root 18 is how much? 3 root 2. 3 root 2. Root 2 will go. AB is to AC is equal to 5 is to 3. The vertical angular theorem says AB is to AC is same as BD is to DC. Now you have got the ratio 5:3. 5:3. Now what we have to do? The ratio, you know, the endpoints, you know, you have to apply the ratio of division formula. What is the ratio of division formula? mx2 plus nx1 by m plus m. This part. Okay. Now 5 3 is 15 plus 0 by 5 plus 3. Then 5 2 is 10 minus 6 by 5 plus 3. Then 5 1 is 5 minus 6 by 5 plus 3. So the answer going to be 15 by 8, 4 by 8, and 5 minus 6 minus 1 by 8. Right? Is it 5, 3 to the plus 6? This is plus 6, 3 to the plus 6. Here, this is not minus 2. So this will be 11 by 8. So the answer is E. Just you check. Now this entire sum is based on the concept of the vertical angular theorem. The vertical angular theorem says what? The vertical angular bisector divides the base in the ratio of the sides containing the angle. Angle A is contained by, angle A is formed by AB and AC. So what is AB length distance formula we found? AC length distance formula we found. Then we applied BD is equal to DC is to BD is to DC. The ratio in which the angular bisector divides is nothing but AB is to AC. And then we proceeded to find out the ratio of division formula. What is the ratio of division formula? Yes, mx2 plus nx1 by m plus n. That we have applied. Now we will take up a next question. Okay, next question we will take up. Yes. The next question here is the line passing through 5 1A and 3B1 crosses the YZ plane at 0, 17 by 2, minus 13 by 2. Then A is 4, B is 6, A is 6, B is 4, A is 8, B is 2, A is 2, B is 8. Give a reading to the problem. Give a reading to the problem. Yes. Right. Now, you know that the line equation solution. What is the line equation in a two-dimensional, which you are very much familiar? Equation of the line through is, so x minus x1 by x minus x1 by, rather you will write like this, no? Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. What is this? Tell me. What is that? That is a 2-point form of a line. 2-point form of a line. Correct? Yes. Now next, but then next, what else I can do? I will adjust like this. Y minus y1 by y minus y1 by y2 minus y1 is the same as x minus x1 by x2 minus x1. This is the equation of the line in two-dimensional geometry, passing through what? Y x1 y1 and x2 y2. In three-dimensional geometry, what happens? You will get one extension. What will be that extension? Z minus z1 by z2 minus z1. So, what is the formula governing this particular question here? What is the formula governing this question here? So, the required formula is x minus x1 by x2 minus x1 is y minus y1 by y2 minus y1 is z minus z1 by z2 minus z1. Yes, this is the equation of the line passing through two given points. Got it? So, what is the x1? X minus 5 by x minus 5 by what? X minus 5 by 1, 5 minus 3, 5 minus 3 minus 5, that is minus 2. Then y minus 1, y minus 1. Got it? Y minus 1 by 1 minus, rather b minus 1. Yes, then z minus a divided by 1 minus a. 1 minus a. This is the equation of the line. So any parametric point on this line, means each fraction you take it as a lambda. Got it? Each fraction you will take it as lambda. This is some fraction, some value. This is some value. This is some value. That value, each value is taken lambda. So if you take the first fraction and the last fraction and find the value of x, what you will get? X is equal to minus 2 lambda plus 5. Y is equal to lambda times b minus 1 plus 1. And z is equal to lambda times 1 minus a plus a. What does this x, y, z give you? What does this x, y, z will give you? X, y, z will give you any parametric point on this line. If this is a line, on that any point is given by this. If this parametric point is 0, 17 by 2 minus 13 by 2. Where is this particular point? This particular point is on the line and on YZ plane also. So imagine this is to be YZ plane, and a needle is pierced through this. So the common point to this plane and that needle, this particular white paper and needle is nothing but the point where the line crosses the YZ plane. So this is the most common point. Such most common point matches with the crossing point. Then x value should match with what? X value should match with whatever is there. What is the x value? So minus 2 lambda plus 5 is your x value. That should become 0. So lambda should become 5 by 2. Got it? Lambda should become 5 by 2. If lambda is 5 by 2, what is the value of this one? Y 5 by 2b minus 5 by 2 plus 1. Here in y, there are two unknowns. What are those unknowns? One is a lambda and one is a b. Okay? So that is equal to 17 by 2. So 5b by 2 is equal to, how much is this going to be? 17 by 2 plus 3 by 2, which is 20 by 2. 20 by 2 is 10. So b is equal to 4. You got it. B is equal to 4. Got it? B is equal to 4. Next, what we should do? We should equate the value of z. What is z, please? What is z, please? Lambda 5 by 2 minus 5 by 2a plus a. That z value here in this point is minus 13 by 2. Minus 13 by 2. So 5 by 2 plus 1. 5 by 2 plus 13 by 2 is equal to 5 by 2, 3a by 2. These two, when you simplify, are you not getting minus 3a by 2? Okay, so 18 by 2 is 9. 9 is equal to 3a by 2. So a is equal to 6. A6, B4. A6, B4. This is the answer. Got it? This idea is important. This is entire success of this problem solution. The student solving this problem depends upon the two ideas. One is this particular formula, then identifying how to identify the parametric point. If the parametric point is chosen, such parametric point can match with the point where the line is crossing YZ plane. Go through the solution. Come up any difficulties? Come up with any difficulties? I will tell you in just a minute. Go through. We will take up the next question. Right. Seems okay. Tell me, Ritvik, what do you want to be explained? What do you want to be explained? Tell me. You want it to be explained again? Okay. Now check the question here. Okay, I will explain again. Check the question here. The question is like this. There is a line. There is a line. It is passing through. It is passing through a YZ plane. This is passing through YZ plane. This point is given. 2 points on the line are given. If 2 points on the line are given, what is the formula for straight line equation? Symmetric form of the line, they call it. What is the symmetric form of the line? X minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. What is this? This is the equation to the straight line passing through x1 y1, x2 y2, x3, x1 y1, x1 y1 z1, x2 y2 z2. So first you try to understand that equation which I have written on the top of the board. That is the formula. In that formula applied for the points given. The points given are 5, 1a, 2. Okay. What are the points given? The points given, 2 points given on the line, no? What are the points given? 5, 1a and 3b1. This formula I applied for these 2 points. I got this equation. This is x2 minus x1. This is y2 minus y1. This is z2 minus z1. X minus x1, y minus y1. Now what did I do? I took what? Each fraction value as a lambda. Each fraction value as a lambda. Then what I will do? X minus 5 by minus 2 is equal to lambda. Can you find x value from here? Yes. X is equal to minus 2 lambda plus 5. Y value is lambda b minus lambda plus 1. These two you take. It is like this. X minus 5 by 2 is equal to minus 2 is equal to lambda. X is equal to minus 2 lambda plus 5. Similarly, take the second one. Similarly, take the third one. So, x value, y value, z value we got. So, this x, y, z will give you the most common point. It can be chosen as any point. If that is matching with this point, the value of x should match with 0. The value of y should match with 17 by 2. The value of y should match with minus 13 by 2. So like that, I equated. When I equated x value, I got lambda value. Such lambda value we are using here. So we are finding out b values and a value. That is the question about. Right. Next question here. Right. then this is this people should able to do. I am taking up this because it was asked earlier one time. Though it is very simple, just I want to make it clear. The concept behind this are midpoints of sides BC, CA and BA of triangle ABC. Then centroid of triangle ABC. Yes, there are two approaches. There are two approaches to this question. Two approaches to this question. The first approach is, can you find ABC? Yes, you can find ABC. Once ABC are known, x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3 should give you the centroid. So actually, I am not advocating that method. Finding, without finding also, you can find. The logic and the formula here is the centroid of midpoints is same as the centroid of the original triangle. What is this? D is x1 plus x2 by x1 plus x2. Let us do it for okay. Even if you want to do it for 3 also, okay, no problem. x1 plus x2 plus x1 plus x2 by 2, y1 plus y2 by 2. Yes, and z1 plus z2 by 2. What is the E? Yes, this is A, B, C, you say. Then x1 plus x3 by 2, y1 plus y3 by 2, z1 plus z3 by 2. What is F? x1 plus x1, A, B, C. Okay, this is x2 plus x3, y2 plus y3, z2 plus z3. This one will be x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. Now, try to find out the centroid of the each x1 will come twice, x2 will come twice, x3 will come twice. Twice divided by 2. x1 is coming twice, x2 is coming twice, x3 is coming twice. So the centroid will become x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So what do we conclude? We conclude that the centroid of the triangle ABC is same as the centroid of the triangle DEF, where DEF are the midpoints of the respective sides. So simply find this DEF triangles. What? The DEF triangles centroid, you will get the required centroid. Should I do the elaborative part of DEF, or is it okay? Okay. So centroid. What is a centroid form? Centroid, just you identify. Have you understood this? Have you understood the concept behind this? The concept is the centroid of the triangle formed by the midpoints is equal to the centroid of the original triangle. Okay, then I'll go to the next question. Yes. Give a reading to the question. The distance between the 2 points A comma B is D, and the length of projections of AB on coordinate axis are D1, D2, D3. Then they are establishing a relation between what and what? D and D1, D2, D3. Okay? Right. Then here, what is the concept used? What is the concept to be utilized? Concept to be utilized is this. Here you see. There is a point P, x1, y1, z1. There is a point Q, x2, y2, z2. These points are projected on a line. So if this point P's foot of perpendicular is taken as P dash, Q's foot of perpendicular is taken as Q dash, then this P dash, Q dash is called what? Orthogonal projection. Orthogonal projection. Orthogonal projection of PQ on L. Check it out. PQ is there. PQ are 2 points. P dash, Q dash are what? The feet of perpendicular on a line L. So, if you want this P dash, Q dash, what does the formula say, you know? L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1. Since this is the length of the projection, it is kept within the modulus. So, what is L into x2 minus x1, m into y2 minus y1, n into z2 minus z1? In this diagram, this gives you this length. These are the length. This PQ is projected in line. So, what are LMN? LMN are the DCs of the line taking the projection. DCs of the line taking the projection. This particular formula is used in this problem. Okay. Now, what is a D1? According to the question, what is a D1? D1 is a projection. Projection of what? Projection of AB on x-axis. So, what is the? Let us take A as x1, y1, z1. B as x2, y2, z2. Right? Then AB projected on AB projected first on what? X-axis. So what is the x-axis? DC is 1, 0, 0. So D will become 1 into x2 minus x1. Got it? This formula only I am applying. L is 1, x2 minus x1. M is 0. DCs of the x-axis 0, 1, 0, 0. So this is this one. So this is a D1 about. So similarly, D2 will be what? 1 into y2 minus y. AB projected on y-axis D. What are the y-axis? Y-axis DCs 0, 1, 0. So that's why D2 will become y2 minus y1. So what will be D3? Z2 minus Z. Got it? Yes, this formula is applied. What are LMN? LMN are the DCs of the line taking the projection. What are x1, x2, x1, y1, z1, x2, y2, z2? The ends of the line segment which is being projected. So this formula applied. So AB is projected on x-axis. So x2 minus x1 into DCs of y. Y2 minus y1 into 0. Z2 minus z1 into 0. Then if it is on y-axis, 0, 1, 0. If it is on z-axis what? Z2 minus z1. Then what is D1 square plus D2 square plus D3 square? You see, D1 square plus D2 square plus D3 square will give me x2 minus x1 whole square, y2 minus y1 whole square, plus z2 minus z1 whole square. This is nothing but AB square. AB square is nothing but, according to the question, it is d square. So the answer is A. d1 square plus d2 square plus d3 square. This can be remembered as a formula. How to remember it as a formula? The length of projection of the line segment on each axis squared and added will give you the square of the distance. Okay, we'll take up one more question. One more question we will take up, right? Right. Check this. A, B, C are on OX, OY, OZ at distances of. To save the time, what I would ask you, as I am reading loudly the question, make a note of the question. Don't copy the answer. Listen to the answer and try to solve it on your own, which you can. So when I am writing the question on the board, for sake of the reference, by my audio, jot down the problem. That is the best way of utilizing this session. Let A, B, C are on OX and OY and OZ at the distances of 3, 6, 9 from O, and Q is equal to 2, 5, 9. P is equidistant from OA, OB, OC, then coordinates of R, which divide PQ in 3:2 ratio. Don't copy the options for sake of visibility. I am writing. As I am dictating the question, as I am repeating the question loudly and writing on the board, you make a note of the question and listen to the solution. Okay. First, give a reading to the question one time. Read the question once. A, B, C are 3 points at a distance of 3, 6, 9, and Q is a point. P is equidistant from OA, OB, OC. So first, let us proceed to find a P. Yes. What is A? A point. Can you list the A point? A is on x-axis. A is 3, yes, 3, 0, 0. So what is the B? B is equal to 0, 6, 0. B is on y-axis. What is the C, please? C is 0, 0, 9. Let us choose P, X, Y, Z. So x minus 3 whole square plus y square plus z square. What does this give me? PA. Okay? PA. That gives me PA. PA is equal to OP. Is it OP? Yes. OA is equal to OB is equal to equidistant from OABC. Equidistant from O, A, B, and C. That is the question, not OA, OB, OC. correct it. The point P is equidistant from O, A, B, C. So from origin distance to P, x square plus y square plus z square. What I am using? I am using OA is equal to OP. So what I will get here? X square plus x square minus 6x plus 9 plus y square plus z square is equal to x square plus y square plus z square. This square parts will go. What it will give me? X is equal to 3 by 2. So the P coordinates in X 3 by 2. I repeat, A is at a distance of 3 units from origin on x-axis. So A is 300. B is 6 units from origin on y-axis. So B is 060. C is at a distance of 9 units on z-axis, 009. There is a point P, which is unknown. That unknown point is known as XYZ. It is equidistant from OABC. Mean OP is equal to OA, OP is equal to OB, OP is equal to OC. So if I use OP is equal to OA, I got X value. Then what we should do? OB is equal to OP. Use that. OB is equal to OP. From there, arrive at Y value. Come up with Y value. OB is equal to OP. Is it given? Yes. Point is equidistant from OABC. So OP is same as OA is same as OP is same as OC. So OB is equal to OP. Yes. Now, right. Then what is the OB? OB x square plus y minus 6 whole square plus z square is equal to x square plus y square plus z square. So x square, y square, z square will go. Here you will have minus 12x plus 36 is 0. So y is equal to 3. Somebody has answered that. Yes, correct. Y is equal to 3. Now my question to you is, can you find the value of z? To find the value of z, what we should use? OP is equal to OC. OP is equal to OC. Find out OP is equal to OC, please. Then you will have 9x, z 18x, x square plus y square plus z square is equal to x square plus y square plus z square minus 18z plus 81. X square, y square, z square will go, giving you 18z is equal to 81. Z is equal to, how much is z? 81, 9 by 2. Z is equal to 9 by 2. So you have got the P coordinates. You got the P coordinates? Yes. Q coordinates already given. So what are the P coordinates, please? P coordinates are 3 by 2, 3 by 2, 3, 9 by 2. Q coordinates provided to us. What are the Q coordinates? 2, 5, 9. The ratio of division 3:2. So the coordinates 3 2 is 6 plus 6 by 3 plus 2. 3 5 is 15 plus 6 by 3 by 2. mx2 plus nx1. 27 plus 9. 27 plus 9 by 3 plus 2. Got it? So this should give you the required one. So here, though this is a straightforward question, there are no twists and turns. The question is taken up because it was asked once in an entrance examination. That's why it was chosen. Now, next question here. for A not equal to 0 if sum of the distances of a point from the points A00 and minus A00 is constant 2k, then locus of that point. This is a question. If the given points, fixed points, are chosen as capital A, comma capital B, then the point undergoing the locus is chosen as P, X, Y, Z. So what is the condition given to us? PA plus PB. So solution, let A is equal to A00, B is equal to minus A00. So PA is equal to PA plus PB. PA plus PB. The sum of the distances from the points is a constant and is equal to 2k. So PA is equal to 2k minus PB. PA square will become what? X plus A whole square plus Y square plus Z square is equal to 4k square plus PB square. PB square will be what? PB square will be X plus A whole square plus Y square plus Z square. PB square minus 4k PB. Got it? PA is equal to PB. PA plus PB is 2k. PA square, squaring both sides. Here, this PB involves what? PB involves some square root. That's why I have not applied the root part. I have not applied. Now, when you square it up, what happens? So, this is x plus a. This is x minus a. This is minus a. So, x square minus 2ax plus a square plus y square plus z square is equal to 4k square. 4k square. Yes. 4k square plus x square plus 2ax plus a square plus a square, got it? Plus y square plus z square minus 4k pb. This y square z square part will go. Then x square part will go. Then the 2ax can be brought here. A square part will go. So 4ax, that also minus, yes, minus 4ax is equal to, minus 4ax is equal to 4k square minus 4k pb. That 4 cancelled off. Ax minus ax plus k square is equal to ax plus k square is equal to kpb. One more squaring is needed. Okay, one more squaring. One more squaring if you are done. If you have done one more squaring, what happens? A square x square plus k power 4 plus 2akx 2ak square x is equal to k square into x minus pb x plus a whole square. So k square into x square plus a square plus 2ax. 2ak square, k square x square plus k square a square, 2ak square x. That part has gone. Okay. Then along with this, you should have k square into z square plus y square also. Got it? Then what else? X square part, let us transpose the other side. A square into x square. 1 minute. PB is understood. PB is how much? Under root. PB is under root x plus a whole square plus y square plus z square. For that square I have done. For that square I have done. Now the adjustment of the terms. So what are the terms left over? Terms left over there. So a square k power 4, let us keep it here. K power 4, let us keep it here. Minus k square, a square you bring here. The other side is k square, x square into k square minus a square. Okay? Then this k power 4 is retained here. This k square, a square is thrown here. 2kx had got cancelled off. Plus what else we are left with that? K square into z square plus y square. Now divide, what is this k square can be taken common? K square minus a square is equal to x square into k square into z square plus y square. Now divide by k square a square. So this is k square is equal to x square into x square. This k square a square part will go, giving you k into z square plus y square by k square minus a square. This is the locus. Right? Then next question here. The direction cosines of two lines are related by L plus 3m plus phi n is equal to 0. Phi lm minus 2mn plus 6nl is equal to 0. Then angle between these lines. A, some cos inverse 1 by 8. B, cos inverse 1 by 3. C, cos inverse 1 by 9. So on. Okay, this is also a very standard model, might be familiar to you. What is the logic behind this and what is the approach and what is the logic for that approach, I will explain. How many unknowns? 3 unknowns. What are they? LMN. So to determine uniquely how many conditions you need, 3 conditions you need, but you are provided with 2 conditions alone. So what you can conclude? You can conclude that the proportionate values of LMN can be found, but not actual values. But proportionate values are okay for us. The proportionate values of DCs is nothing but direction ratios. Once you know the direction ratios, A1, B1, C1, A2, B2, C2, you can apply cos inverse A1, A2 plus B1, B2 plus C1, C2 by under root A1 square plus B1 square plus C1 square formula to determine the angle. Okay. So what is imperative now? Imperative is finding out the proportionate values of LMN. So eliminate one parameter, preferably such parameter which will not give you any denominator in expression. When it is made as subject, such parameter should not give you what? The denominator in it. Check. L is equal to minus 3m plus phi n. Okay, that you substitute in the second equation. So what you will have? Minus 15 m square minus 25 mn, okay, minus 2 mn plus minus 6 3s are 18 mn, yes, minus 13 n square is equal to 0. So the value of L obtained from the first equation is substituted in the second equation. There is no fixed thing which is to be eliminated. You can eliminate either of them. Okay. Then what happens? Then how much is m squares? 115 m square. How much is mn? 25 to 27. 27 plus 18, 45. So 45 mn plus 30 n square, 0. 15 cancelled off. M square plus 45 mn. 27, 45. So 3 mn plus 2n square is 0. This is factorized. M square plus 2mn plus n square plus 2n square. Mn plus 2n square is 0. So m into m plus 2n plus n into m plus 2n is 0. So either m is equal to minus n or m is equal to minus 2n. So what you will do? If you put m is equal to minus n here, m is equal to minus n. L is equal to minus 2n. So L is to m is to n. In place of L, minus 2n. In place of m, minus n. In place of n alone. So what you will have? N getting cancelled. Minus 2, minus 1, and 1. These are the ERs. What did I find? I found the ratio of what? Ratio of DCs. Ratio of DCs are DRs. So next, m is equal to minus 2n. M is equal to minus 2n will give me 6n. So L is equal to n. L is equal to n. So L is to m is to n. L is to m is to n will give me what? N is to m is how much? Minus 2n is to n. So n getting cancelled, 1 minus 2, 1. So cos theta is equal to minus 2 plus 2 plus 1 divided by under root 4 plus 1 plus 1 under root 1 plus 4 plus 1. So what you are getting now? So the numerator is 1 by 6. Cos inverse 1 by 6 is the answer. This model is repeatedly asked in MSAT or BITSAT or something. So try to understand the model here. The model is first express one parameter in terms of other, eliminate, you will get a quadratic, you will get m in terms of n or anything. So totally you are finding in only one parameter. The ratio, if you are finding such parameter is getting cancelled, ratio of DCs is nothing but DRs, then you are calculating the cos theta. Okay, now next one. So next one is a standard one. What are the question is, what is the angle between diagonals of a cube? Come up with the answer. And I will write a question on the board. Yes. Now, a straight line makes an angles of alpha, beta, gamma, delta with 4 diagonals of cube. With 4 diagonals of cube. Then which of the following is true? A, cos square alpha, cos square beta, plus cos square gamma is 4 by 3. B, sin square alpha, sin square beta plus sin square gamma is equal to 8 by 3. Then cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to minus 4 by 3. This might be a familiar question to you. Let's attempt this. Right? Sure. Next here. If you take the cube having coordinate axis as part of the coordinate axis as its edge, this is the y-axis, this is x-axis, this is z-axis, then this is 0a 0, this is 0 0 a, this is a 0 a, and this is a, and this is 0 a. These are the, this is 0 0 0. This is familiar to you? Yes. Now let us take this as A, this as B, this as C, then this is P, this A, B, C, D, and this as E, and this is P. This is F. This is F. This is G. Okay. Now, can you calculate the DCs of the diagonals? Diagonal AB. Diagonal AB. What are the DCs? 1 by root 3, 1 by root 3, minus 1 by root 3, and yes, minus 1 by root 3, and AB, AE, diagonal AE. If I take a diagonal, what do you have? 1 by root 3, minus 1 by root 3, and 1 by root 3. Diagonal AE. Diagonal CF. Diagonal CF. Yes, diagonal CF. This will be A0. So 1 by root 3, 1 by root 3, minus 1 by root 3. These are the DCs. Then next diagonal DB. Diagonal DB. Diagonal DB will be minus 1 by root 3, 1 by root 3, and then 1 by. What else is diagonal left over? FC diagonal is left over. Diagonal FC, diagonal FC. What is the diagonal FC then? 1 by root 3, 1 by root 3, FG, CG, CG, 1 by root 3, 1 by root 3, 1 by diagonals. So you will have cos square alpha plus cos square beta plus cos square gamma plus cos square delta is equal to this line making the angles alpha, beta, gamma assume as LMN. Okay, so L plus L minus M plus N by root 3 whole square plus L plus M minus N by root 3 whole square plus minus M plus root 3 plus M plus N by root 3 whole square plus L plus M plus N by root 3 whole square. If you observe the two AB terms, when you expand A plus B plus C whole square, the 2AB, 2BC, 2CA, these terms pairwise they get cancelled out. Pairwise they get cancelled out. Only the perfect square numbers will be left over. So there will be 4 by 3 L square, M square, N square. So this is equal to 4 by 3. So then you write cos square as 1 minus sine square. Okay? Cos square you write as 1 minus sine square. So sine square alpha plus sine square beta plus sine square gamma will be 4 minus 4 by 3, which is equal to 8 by 3. Now these two relations we have got, no? Cos square alpha minus sine square alpha. What will be that? Cos 2 alpha comma cos 2. Cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to 4 by 3 minus 8 by 3. 4 by 3 minus 8 by 3 is how much? 4 by 3 minus 8 by 3 minus 4 by 3. So that is the answer. Got it? So in the next session, we will take up the planes and the lines. So what are the topics of the examination? You know, topics for the examination are whatever the syllabus covered up to now. That doesn't include three-dimensional geometry. Three-dimensional geometry we are doing for 2 days. So the remaining syllabus you do. Okay? Right. Any doubts you raise? Any doubts you raise? Anybody having difficulty in the questions? You can raise. This question, any difficulty you can raise. Right. Then do we have time for one more question? Santosh, should I continue? Should I take up one more question? Okay. Now we'll talk about the planes. We'll talk about the planes. Yes. Surface. What is a surface? Surface is a locus of points. Collection of points is a surface. In the plane, any XYZ relation will give you a surface. But that surface need not be a plane. When a surface becomes a plane, if the line joining any two points on the surface is wholly contained by it, then such a surface is said to be plane. Okay. Right. So see here, you have this particular paper as a plane surface. On this surface, if you take up any 2 points and join the line, that line will have infinite length or indeterminate length. So you have to imagine that you have thrown up a kerchief in the air. That kerchief is getting expanded. How it is getting expanded? It is getting expanded infinitely. If this is the part, this is the finite part. If you are joining 2 points on A, B, then this line goes on extending. As the line goes on extending, the surface also gets expanding. Such surfaces are said to be planes. Now, the plane in general is equivalent of a straight line. The straight line concepts more or less hold good for plane. So, plane, different forms of the plane we will explore. Different forms of the plane. Yes, planes. So first, what is ax plus by plus cz plus d is equal to 0. This is a plane. This plane equation is known as the general form. The general form of the plane. What are coefficients a, b, c are known for? The coefficient a, b, c are known for the drs of a normal to the plane. Normal to the plane. drs. Now, if the plane makes intercepts of ABC on x-axis and y-axis and z-axis, then x by A, y by B, z by C is equal to 1. This is known as the intercept form of the plane. Okay. Then next we have a equation to the plane passing through 3 given points. What are the points? x1, y1, x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0 determinant. This is the equation to the plane. Equation to the plane through x1, y1, z1, and x2, y2, z2, and x3, y3, z. Okay. In the next session, we will explore the relationship between the line and the